All right, good morning. This is the bi-weekly meeting of the Storage Special Interest Group. Today is April 13, 2017. As a reminder, this meeting is public and recorded. And let's kick it off. Today on the agenda, we have, so the face-to-face meeting was held earlier this week, yesterday and the day before. It was pretty well attended. Props to Dell EMC for hosting. The notes from the meeting are in the agenda doc. Does somebody want to take the time to summarize some of the things that were discussed? Brad or maybe Steve?
Are you asking if we... Yeah, I can go over the notes. Is that what you're...
Sure, yeah, we could do that.
So I think the biggest topics that we kind of drove to somewhat of a conclusion were around our snapshotting and local storage. And let me pull up the notes here. Yeah, so we had a pretty extensive talk on our snapshot design, and where we've pretty much come to the conclusion that we need a namespace and a non-namespace object. There's still a little bit of question if we can use a sub object, or if it needs to be a snapshot object and a snapshot claim or request separately, and we're working that. But generally, the overall design was pretty much approved, and we've left it up to the developers working on it to finalize the design and then post that in the next couple of days. There's a pretty extensive, blow-by-blow, play-by-play in the notes if anybody wants to go over that and see, how we arrived at everything. Then we had a pretty long talk on the CSI Initiative. We talked, we went through the different API calls. We had to kind of give an overview of how everything worked. Then we had a talk of the timeline and how it would coordinate with Flex. And the idea being that this was pretty much one-to-one with the Flex 2.0 model. So there's for anybody that wants to see exactly how the discussion went, it's in the notes. There's also a pretty long design document for CSI, and people are welcome to leave comments there. Then let's see, we talked about security very briefly. We went over containerized mount and some of the problems that exist right there. And I think our current plan is to work on some of the prototyping for that, and I know that Jan's working on the design and some of the implementation, and plans to have somewhat of a design posted here in the next, for 1.7, and then we can use that for to vet some of the CSI containerized work. Local storage. So we had a long discussion on local storage. Again, there's another great design document out there full of details if anybody wants to go and review that. We walked through pretty much every aspect of it. There was various concerns that were brought up, but I think it's on track and it's going in the right direction. The takeaway is I believe a couple of us are going to get together and have somewhat of a small working group and flesh out the remaining details, and then have a design. Not sure if we were targeting that for 1.7.
The local storage stuff?
Yeah.
I think alpha is targeted for 1.7.
Okay, so not just the design 1.7. We do plan to have an alpha for 1.7. Okay. And as part of both CSI and the local storage, the question of block storage came up, and we're also looking at coming up with a design for that, probably for the 1.7 timeframe as well. talked a little bit about resource management and isolation. So this was some discussion about logs and the other local node resource constraints. There's more blow-by-blow notes in the doc, and then that was pretty much it. I think the big stakes that came out of it were snapshotting, local storage. Oh, and we had some discussion around resize, and if we could use modification of the fields in the PVC as trigger points for resize or other imperative operations. I think we decided that, short of a proof of concept, we all thought that could be possible. And we didn't really have next steps after that. It was more of, is this the design path we want to go? And I think we're still waiting to figure out what our next steps are. So that's the high level. If you guys want to look at the details, there's a great document out there with all the notes. And then there's links to all the other design documents from that.
All right, thanks, Brad. Does anyone have questions about anything that was discussed or the summary of the face-to-face? All right, then we can move along. Next item on the agenda is status updates on the work in progress. I'm going to pull up the spreadsheet over here. And we can go down line item by line item. First up, NFS wedging issue. Hemant, do you have an update on this? Looks like Hemant might not be with us today. Brad, do you know the status of this possibly?
No, I haven't heard the status on this one.
Okay, we can catch up on it next time. Stabilizing AWS support for EBS. Jing, do you have any updates on this? No, looks like we do not have Jing either. Day after KubeCon or after Storage SIG face-to-face is not the best time to have this meeting.
So Saad, I know that we've ran into some issues with AWS, and we'll probably be adding them upstream. Hemant's been working on this also. There's a couple blocker issues that we have. I'll probably be pinging you offline to talk about that.
Got it. I think a couple of folks that we met at the storage face-to-face were also very interested in helping out with AWS work. But based on my discussions with Jing, it sounds like there are workarounds in place that have mostly stabilized it. There's probably larger refactors that need to be done, and her and Justin are going to help lead those. Next up, out of volume plugin CSI. The early design draft of this was presented at the face-to-face. Like Brad said, the meeting minutes capture some of the details. We're going to continue to revise and improve on this design. I think one of the big pieces of feedback was around the list call and how to do pre-created volumes. We're going to chew on that for a bit and see if we could come up with something better. So that's work in progress. Next up, local ephemeral storage, capacity isolation. I think Jing has primarily been working on this. She has a prototype out showing some of the design that she showed off at. She showed the design at the face-to-face, but she also has a working prototype. So I think we're in good shape for alpha for 1.7. Local persistent storage. Michelle, are you on the line?
Yeah, I'm here. Can you hear me?
Yep.
Yeah. So I think basically, yeah, we also are in the same boat, kind of. We have a working prototype going out, and I think the design is so far making progress. The only last thing remaining is the scheduler part, which is the hardest part. So we're trying to see if we can at least come up with a design for the scheduler in 1.7. I'm not sure if we can actually get some code in for 1.7 for the scheduler, but I think the rest of the components are more straightforward, so we can definitely still get those in.
Got it. Excuse me. Thanks, Michelle. Next up is our testing effort. Jeff, do you have any updates there?
unmuting. No, but thanks for getting, I mean, related to the wedge kubelet, I did, with Saad's help, we got a test, E to E PR merged last night, which does one test example of trying to make sure kubelets don't get wedged when there's problems with the NFS server running. But no, we're just plugging along. We've gotten a lot of good review feedback on our recent PRs, and I think it's just chipping away at it, Saad. There's nothing specific that comes to mind. Maybe Don has some.
There was somewhat of a question about how do we get new folks more involved in the community? Where do they start contributing? We're going to have a bigger discussion about that at the next Storage SIG meeting. But my quick thoughts on that is I think a lot of the work that we have left for testing is a really great spot to start. We have a big spreadsheet that Aaron helps maintain for tests that we'd like to write. And writing tests is a really, really great way of getting familiar with the system. So anybody who's interested might want to reach out to Jeff or Aaron about where they can help out. But we can have a bigger discussion about that next time.
Yeah, for sure, Saad. I did volunteer at the face-to-face to help anyone sort of start ramping up in Kubernetes with some low-hanging fruit related to testing.
Awesome. Thanks, Jeff.
Mm-hmm.
So next up is cloud provider storage metrics. As far as I know, this was checked in. There are some issues with the way that this was coded. I believe Bowie on our side is taking another look at it. He's implementing metrics for networking. And so he's probably going to do a refactor of this code, and he'll probably include Hemant in that code review as well. The metrics for the volume controller, I'm not sure what the status of this is. Mohammed, are you on the line?
I believe we had something merge on this recently.
Okay, so this should be good. Okay, moving on. Schedule by node capabilities. I think we could drop this item since it's going to be part of the CSI design. We discussed a little bit about this during the CSI presentation. So I'm going to go ahead and remove this line item and stop tracking it separately. Next up is snapshots. To Monster Jing, do you want to give an update?
Well, yes. So there's been quite a big progress made in the past week. We have basically a proposal that's been agreed on the face-to-face. So I guess we need to capture this in the proposal document itself, and that's about it. So I think we've made a huge progress.
Awesome. So code freeze, I believe, is the end of, excuse me, the end of May for 1.7. So it looks like we have plenty of runway for getting code written.
Hopefully, yes.
Next up is data replication. Serge has been working on this. Serge, do you want to give an update?
As far as application proper progress, there was no progress. Application work became dependent on the dynamic changes to the PVC in order to control operations related to replication, in order to be able to express, enable, disable, this kind of things. So as far as application proper, nothing has been done, but there is a proposal for dynamic changes to the PVCs and PVs that was discussed on the face-to-face, and I'm going to be working on next level of details there.
Got it. Thank you. Do we want to track the dynamic update of PVC as a separate item on this spreadsheet?
I would suggest that's a good idea.
Okay.
And as soon as I get the next level of details, I think it would make sense to start discussing the target deliver.
Got it. And would we want to target a design doc for this milestone, or do we want to go alpha?
No, design doc first.
Design doc, got it.
Yeah, because I mean there was a lot of good questions asked on face-to-face, and that definitely needs to be detailed one step deeper, and that's design doc.
Okay. Cool.
And I don't know if you're expressing here somehow the dependency that.
Yeah, I don't think we've got a good way of capturing dependency.
Because as far as data replication, as of right now, I don't see any way and any reason to make any progress there before we get this done.
Yeah, maybe I'll just shift it up so it's there together. We'll just have to remember. I can do that later. Okay, next item on the agenda is, or next item in this status update, attach detached controller restart handling. Tomas was working on this. Tomas, is this something that's waiting for a code review?
Right now, I've pushed the new version that should be fixing the problem that has been discovered. So yes, I would really like people to take a look because I'm not quite sure about the latest fix, but it seems to be working in my environment. But
Is
again,
the
it's rather big, so.
is this the correct PR, or is the PR linked from the issue 34242?
Yeah. That's
Cool.
the correct one.
So let me give a little context on this. We have a couple like crit sits right now, and well, let's just say we have some crit sits right now, and they are around some of the issues, around some changes or some problems in attached detached that are fixed by this PR. I know that we've gone through a couple iterations of like tests and retests as we found like different issues, and we've fixed some of the other problems that we've found right here in this, in this fix. So it's not just refactoring. There's also a couple bug fixes in this.
You got it.
And it's kind of getting into a hairy situation because there are some critical fixes that are wrapped up in this change. And so we're hoping that we can, escalate somewhat.
Okay. I'll see if I can prioritize this hire for code review, and anyone else who's interested in this should take a look at this PR as well.
And I know it's a super complicated piece, right? And we're not going to be able to test or vet every angle of it until it merges, is quite frankly the truth.
Until it gets merged and has some time to bake.
Yeah, and exactly.
Okay.
But after it merges, I mean, we will be on call or whatever, so if there's if people find issues or bugs with it, it's something we can address quickly. But we've vetted it pretty well and are fairly confident.
Okay, so it looks like it's just a matter of getting it code reviewed and merged and letting it bake.
Yep.
Cool, sounds good. Next up is stabilizing Azure support. There were a set of bugs here. I think a couple of them are linked. Wamin is owning this, but I don't think he's on the line. The linked pull requests are already in place. We need to review them. I have that on my to-do list to review along with Tomas's changes. If anybody else wants to help out with that, feel free to look at those PRs. Next up is stateful applications via federation plane. We don't have an owner for this. I think it depends mostly on the federation side. We kept an item just in case to track things for the milestone. We may end up dropping it. We need to sync up with the federation folks and see if there's any plans for this milestone for this. PV capacity usage stats. I don't believe Jing has had an opportunity to work on this yet. We'll keep it on the status and see if we can make any progress on it over the next month or so. Provisioning configuration in PVC. Jan, do you want to give an update on this?
I have a proposal on a review for a couple of months already.
Oh, wow.
And kind of stalled.
Okay. Is it this?
Yeah, I think so. However, I'm not sure if it is still valid with the current topography design in local storage. Maybe it could be updated.
To reflect the local storage design?
Yeah, it would be nice if somebody, Michelle or you, reviewed it with regarding the
Yeah, so I think
topography.
Saad, you, me, and Vish sat down for a while to discuss this a little bit. I think we were mostly concerned about the zone use case where you're allowing users to be able to specify a range of zones. I think for that, we wanted to move to a model where the scheduler could decide from a range of zones and have pods be limited. You know, if you want to limit like a namespace or something to a set of zones, then that could be controlled, you know, from the pod level.
Mm-hmm.
But I think that, I mean, I definitely see a use case for being able to, for a user to select a specific zone if they want to. I think the main thing we were concerned about was a user specifying a range of zones.
Okay. I think initially this configuration was meant for stateful sets, that each pet would end up in a different zone so they can fail over. So I think only one zone could be okay there.
Yeah, because I think with, well, actually, I don't know if we don't have any, we do have zone spreading logic in the.
Yeah, but it's just a dirty hack.
Yeah, but I mean, if we could improve that zone spreading logic and be able to define some, you know, zone constraints at the pod instead of at the storage, I think that would align better with
All right, we
storage as a first-class scheduling entity.
We can have like zone affinity, anti-affinity.
Yeah.
So no two pods end up in the same zone. That's already possible, right?
Mm-hmm.
Okay, so cool. Even better. Maybe we don't need the zones at all.
I think, I mean, I can still kind of see a case for like specifying individual fields or individual values. Also for non-zonal use cases, like the other ones you mentioned, like encryption, you know, I think this makes sense for those too.
The problem is with this proposal is that it uses selector. So, and in selector, it's impossible to restrict it to just one zone.
So I think Vish's idea was maybe we should, because of that reason, pull away from using a selector and maybe just use labels.
Or have just like a map.
Right.
Map of what? How it would look like? Or can we set up a different call when we can discuss this? Or maybe on email?
Yeah, that should work.
Sounds good. So let's take it offline into a separate call. Hopefully you can continue to make some progress on this.
Yeah. Cool.
Thanks, John. Thanks, Michelle. And last up is dynamic update of pvPVC, which Serge is helping lead. All right, that is the status.
Yesterday I edited the containerization. I don't know where it went. I put it into the bottom. Now I don't see it there.
Maybe I need to refresh. Let me.
I don't know. It was there yesterday. Anyway, I can put it there again.
Okay.
I'm optimistically aiming at 1.7 with alpha, but it's very
containerization of mounts. Let's say improve containerization of mounts, and the status of this is, whoa, what happened here?
You pressed Control R.
Oh, well, we'll have to fix that later. Okay, so the status of this, we discussed it at the face-to-face meeting. Jan has a proposal out to try and improve the containerization of mounts. There's already a kind of hacky version of that in the existing code. His proposal looks pretty solid, and it looks like it aligns with a lot of the work that we will eventually need to do for CSI anyway. So it sounds like it would be a worthwhile pursuit. And Jan is targeting alpha for 1.7. Anything you'd like to add, Jan?
No.
Okay.
I'll see some proposals and this stuff later.
Great. Thank you very much. All right, so that is the status update. Let's go back to the agenda. PRs that need attention. Shared mounts on GCE, end-to-end test environment. Got it?
Yes, that's mine.
Okay.
I should put it there. So in order to have containerized mount, we need to fix GCE environment, which runs Debian Wheezy, and every mount is private there. So we cannot export anything from the containers. So this is a proposal or PR to make root as shared during boot. And in my opinion, this is quite dangerous thing to do. So this needs some consensus. I sent email to SIG Node and to Kubernetes Dev, and the only person who responded was Wish.
Yeah.
So I would like to attract more attention, like something is happening. It could be dangerous because I don't know what I'm doing.
Is there any way we could limit it to just marlib kubelet?
For containerized mount, yes, but there is a proposal to export any directory.
Mm-hmm.
Yes, that's the proposal.
Mm-hmm.
And I'm sure people will do crazy things with that once we allow that.
Yeah, we need to be very careful here.
And I don't know who can decide something like that.
Well, so hang on a second. So sure, we care about it. I mean, we have to have this set up for the E2E test environment.
Yeah.
But I don't think we're creating an exposure surface area that's bigger, to hacks or anything like that in the E2E environment.
Not now, but we are going to implement the proposal in the end, I think.
Oh, right. What I'm leading to is like, we're not touching every operating system out there. This is pretty much a concern for the E2E setup primarily, right? And then I think we probably, I would guess that Google would want to do a security audit on the GKE side of things and make sure that, they are confident that it's secure. So really vet every system, D system, or I'll speak on behalf of Red Hat. We'll do our own security audit that this will work and not cause problems. So I think there's like individual responsibility to do the security audit piece of this, but we don't need to take the whole burden on as like community. You see what I'm getting at?
Mm.
So we need it to work in the EDE, which I don't think is necessarily a security problem in itself. We probably want to note that there is potential security surface area here that needs to, needs to be audited on a OS by OS basis, and then probably GKE will want to do some kind of security audit on their own. But I don't think that we will need to take that burden because we're going to, we will take the burden for Fedora and RHEL, obviously, and anybody else that wants to enable this on a system-wide.
Well, actually, I checked recent GCI, Fedora, RHEL, CentOS, Ubuntu, what else? Debian, Jessie, and CoreOS. And all of them are fine, except Debian Wheezy, which powers our end-to-end tests. So we just need to fix this Debian Wheezy.
Who owns those containers? Do you know?
It's not a container, it's just infrastructure.
It's the infrastructure in GKE, correct?
GKE runs, it runs GCI only, right?
It supports both. So there's the GCI image, which is based off of Chromium. And then there's the old Debian-based image that I guess you're running into issues with.
And is it VZ or GC?
I don't remember.
Because GC is fine.
Okay, so,
Every distribution with systemd is fine.
I see.
so to be very specific, we just need someone that can represent the security audit for this GCI piece, correct? That's probably somebody on the Google side of things.
Yeah. I'll see if we can find a contact to take a look at this.
Okay, or just somebody that knows of a contact. You know, if you can just get us like pointed in the right direction, we can probably start sniffing it out.
Okay.
And this is prerequisite for exporting any mounts from containers. So we can't do anything without that.
Cool. All right, next up, I think Hemant added a quote, fix miss Pod updates.
Yeah, so there's an issue open, which is like the race between pod informer and node informer, and that this PI kind of fixes tangentially, I mean indirectly. I think Jing knows about it. So Saad, you have reviewed it already, and I just want to discuss like couple of things that like the way we are like how we want to fix this problem, because this is one approach which is like this PR, what it does is it uses desired state of world populator every 1 minute to update the pods that are running. Now the concern that Andy has expressed on the PR is like there's two approaches, either using the polling or we can introduce the worker queues that other controllers use to ensure that we don't miss events. If the node is not synced and a pod event arrives, then currently we discard that pod event if the node doesn't exist in actual state of world, right? So actual state of disaster of world, it doesn't exist in disaster of world. So we just need to decide the approach that you want to take for fixing this. And I just wanted to see what everyone's thought is on that. So the bug is basically, the problem is like, if controller doesn't know about a node and a pod event arrives that a pod has been added, then that pod is discarded and controller doesn't know anything about that pod. So if user goes ahead and deletes the pod, the volume will not be detached because the controller doesn't know about the pod.
So to make sure I understand Andy's comment, is it that this is currently relying on the informer cache, and the informer cache could potentially be out of date?
That is one, and second is it's going to like poll every pod in the system, like 200,000 or whatever pods you have. It's going to iterate through that list of pods, and it's going to check.
Yeah, and part of this, one thing to keep in mind is cloud providers that have API quota. You know, if you have a couple hundred nodes and you're doing a
So this isn't hitting the cloud provider at all. It's it's internal. It's basically hitting the internal controller cache. I am not sure what the performance impact of 100K or 250K pods could be, but since this is mostly in memory, I'm not sure how horrible it would be. There's no network calls going on here. You've got a pod lister list, which will end up hitting the informer, and the informer will basically give you a humongous list of pods. I imagine you could have memory issues depending on how that's implemented. Maybe worth testing. So what's his workaround for this? Instead of this, what does he recommend?
Originally we discussed implementing worker queues, like the other controllers use a keep a worker queue. So if a pod event is arrived and we don't have the node, then we add it to the queue and then process it later.
But that doesn't necessarily, that handles one version of the problem, right? But there's other reasons we could miss an event, basically, right? And we don't want to, the idea with these populators is that we go back and we double check our work, right? There's this escape hatch that goes, I think everything is okay, but let me go ahead and verify. And currently what the populator does is it goes out and says, for all the pods that I am tracking, let me go ahead and verify that they are actually still, that they still exist. And if they don't, I'll go ahead and trigger the detach process for them.
Yeah.
And you're implementing the flip side of that, which is maybe there are some pods that I'm not aware of that I should process. And I think the logic there makes sense. It adds a lot of robustness to the existing code. The concern about a large number of pods could be valid. I think they could possibly wreak havoc on memory, but we kind of do this with the flip side of this, with the deleted, but that's actually a little bit smaller since it's only pods that already have volumes, and this would be all pods. So I would suggest maybe running some tests, scale tests, and getting some data, and then going from there.
Okay. Okay, let's do that, and we can work on this offline. Yeah. Okay.
Cool. All right. Nobody put anything down for design reviews this week, so we're going to skip that. And our last item on the agenda today is a demo by Michelle about persistent local storage. Michelle, take it away.
All right, thanks, Saad. Yeah, so after the discussion we had at the face-to-face yesterday, a number of people were interested in, trying out our prototype code that we have already. So I thought it might be useful to just kind of demonstrate how it works, or not necessarily how it works, but how to use it. So I'm going to share my screen. Let's see. All right, can you guys see my screen?
Yes.
Yes.
Okay, great. So here I basically have a cluster of 5 nodes that you can see. I've pre-deployed them with some local SSDs, and they're all automatically, on the GCE environment, they automatically get partitioned and formatted. So they're already all set up and ready to use. If you see right now, I have no, I do, oops. That was a mistake. Okay, I already messed up the demo already. Let me undo. So yeah, I already have this running. Let me delete this so I can show you from the beginning. Okay. Oops. What did I call this? No, I don't have that. That's strange. Oh, sorry. I know why. Because it's a daemon set. There we go. Okay, let's start from scratch again. There are no persistent volumes in the system. Great. So now I have my example static provisioner or discovery, local storage discovery daemon set. That's under here, under local discovery. So this is just a Go program, and when you compile it, you can push it as a container image to the container registry. And once you do that, then you can just launch a daemon set. I have a daemon set defined here, which uses my static provisioner image, and it launches this kubectl proxy in order to be able to talk to the API server. That should be already there and available. So I'll just launch this. I'll just launch this daemon set. Let's take a look. They're all running. And it created persistent volumes for all the SSDs in the system. The capacity currently is just hard-coded, so ignore that value. But basically, I have 2 SSDs on every node, and you can see it has created two persistent volumes for each of the 2 SSDs there. Okay, great. I have persistent volumes now. Now I can have an application to use them. So I have this stateful set application here. It's currently, all it does is just it's a bash script right now that just echoes the name of the pod to a file in the volume. So here's the volume definition for my stateful set. This is just a persistent volume claim. I reference the storage class. I reference how much storage I want. This is not the API that's in the spec. This was like one of the older API proposals. So this will actually be unnecessary in the actual implementation. All you have to do is specify the correct storage class. And from the storage class, we can figure out if it's a local volume or not. So that's my stateful set. I'm going to go launch it. Let's look at the pods. All right, it's already created 2 of the replicas in the stateful set. I have 3 replicas specified. Let's look at the PVCs that got created. There are 3 PVCs that got created, 1 for each replica of the stateful set. It looks like they got bound to some SSDs or some PVs. We can take a look at all the PVs here. We'll see 3 out of the 10, they're now bound to these PVCs. All right. So now in my stateful set app, it's basically a bash script that's writing to a file on one of the things. I have a subsequent reader application here that's just, it mounts one of the volumes of the stateful set and reads the data that's there. So if you look here, it's another bash script here. I'm just tailing the file. And here in this application, it is specifically mounting one of the PVCs of the stateful set. So if I go ahead and launch that there, let's look at the pods. Let's look at the logs of the reader. So the reader container is basically outputting the contents of the volume. If we come here, we'll see the contents. This is local, it's logging. So we see that the stateful set container is logging every 10 seconds. It's logging its name, which is this guy. And then this count is basically the how many times has it restarted. So I just brought it up, so it's at 1. So let's actually just kill the pod. Let's kill this stateful set pod and see what happens. We'll see. So before I killed it, it was on this node. Because it's tied to the local disk, when it restarts, it should get restarted on the same node. Okay, so it's terminating. The stateful set controller is trying to restart it.
Michelle, real quick, is there scheduler changes in this?
Yes, there are scheduler changes checked into this.
Okay.
It's not the scheduler approach that we're going to take in the end, but it was one of the iterations we were making on the scheduler design. So it's creating, all right, and we saw that it also got assigned or scheduled to the same node again. If we look at our reader pod, where's my reader pod? That's reading the contents. Here we'll see the count got increased to 2 because I killed it and it came back. There's that, and then we can actually go, and if we want, I can delete that. And we can change the YAML file to go attached to a different replica in the stateful set. So we'll change that. I'll change this PVC from 0 to 1. Let's look at local test 1. And I'll launch this again. It's running. Let's look at the logs. So here now we see, now we're attached to local test 1's volume. Here we see it's local test 1, the count is 1 because I haven't killed it. That's just a sample application, reader-writer application that I wrote. I can demonstrate deleting the PVCs now, which actually might take a while. Let's see. Let's delete this. Let's delete the stateful set. I think deleting the stateful set takes a while, so while we're waiting, does anyone have any questions?
How big are the scheduler changes?
You mean the ones we have right there on the prototype?
Yeah.
We basically copied the PV controller into the scheduler.
Okay.
I think you can actually see the scheduler changes if you really want to. We're probably gonna wipe all of it, but the scheduler changes are all contained in, there's a local PV predicate under the predicates folder. You can look at that. It's not really that interesting. It's really just the exactly the PV controller copied over. Okay. Stateful set is deleted. let's see. Okay, those are my provisioner pods. So let's look at the PVCs. The Stapleset doesn't automatically create the doesn't automatically delete the PVCs when you delete the Stapleset. So I'm gonna go and manually delete them because I'm done with the data. So I'm gonna go like this. And then if you look at the PVs, you'll see they've been released now. And then this is where in the provisioner daemon set, we're watching for this release state. And once we see that, then we'll go and clean up the volume and then delete it and then add it back. So, yep, looks like it's there. Ready for use again. All right, so that is all I have to demo. Any questions?
What do you mean by the provisioner will delete it? It will delete the data,
Yes.
Okay.
So it's handling the once you delete the persistent volume, then the daemon set is handling the cleanup and the recreation of the persistent volume.
Okay.
So it's very possible right now. All it's doing is deleting the files, but it's very possible to write some custom deletion policies if you need, some more secure form of delete, like encrypting or writing random bits and other things.
I have a quick question. In the beginning, it looks like I think it was a stateful set that you ran, or something that you ran that created the PVs.
It's a daemon set.
It is the daemon set. So
yeah.
Conceivably, if you have a large cluster with a bunch of disks, you can have a lot of those floating around.
Yes.
So is the end product that the admin will be responsible to keep track of all these daemon sets, or will there be somehow to aggregate? I mean, how would you be able to keep track of them and assign them in a reasonable manner if you have a lot?
How would you keep track of what the persistent volumes, or?
Yeah, the PVs and be able to bind them or assign them to a pod or whatnot.
Yeah. So I mean, if you want to specifically assign some certain PVs to some specific pods, you can modify the daemon set when it's creating the PVs to add some label to it, depending on whatever your policies are.
Oh, I see. Okay. So you could use labels to go directly to what you need. Yeah.
I mean, the main purpose of this is that you don't have to directly assign specific PVs to specific pods. The scheduler will choose an available PV that is suitable for your pod.
Oh, okay. That makes more sense. I must have missed that part. Okay. Excellent. Thanks.
All right. So yeah, that's all I have. Thanks, guys.
All right. Thanks a lot, Michelle. That was awesome. Any other questions for Michelle? All right. We can wrap it up for today. That was the last item on the agenda. Thank you, everyone, for attending, and we'll reconvene in 2 weeks. Have a good day.
Bye. Thanks.
Bye. Thank you.
Bye.